Good morning, learners. This is your School on the Air in Mathematics 9. I am Teacher Gilbert of Benigno S. Aquino National High School, your grade 9 radio teacher. Before we start, kindly prepare your learning materials, your pen and paper, to write your solutions and answers as we progress with our discussion. Stay in a place in your home where you can watch and listen carefully. I am looking forward that at the end of our session, you as a learner will be able to model real-life situations using quadratic functions and represent a quadratic function using table of values, graph, and equation. I am excited to help you learn those competencies. We are now with our 6th week in Mathematics 9. In order to understand our lesson for this session, you need to revisit your understanding on perfect square trinomials and the square of binomials. Also, in the previous lessons, we dealt on the concepts of quadratic equations. Let us have these exercises. On a piece of paper, list down the following quadratic equations and identify the values of A, B, and C. You have 1 minute to do it. Equation 1. X squared plus 9x minus 4 equals 0. Equation 1. X squared plus 9x minus 4 equals 0. Equation 2. 4x squared minus 7x equals 0. Equation 2. 4x squared minus 7x equals 0. Equation 3. Negative x squared minus 15 equals 0. Number 3. Negative x squared minus 15 equals 0. You have 1 minute to do it. Okay, let's see. For equation 1, A is equal to 1, B equals 9, and C is equal to negative 4. Again, for number 1, A is equal to 1, B is equal to 9, and C is equal to negative 4. For number 2, A is equal to 4, B is equal to negative 7, and C is equal to 0. Again, for number 2, A is equal to 4, B is equal to negative 7, and C is equal to 0. For number 3, A is equal to negative 1, B is equal to 0, C is equal to negative 15. Good job! Let us have this one. On a piece of paper, write the following expressions and expand them. Number 1. The square of x minus 9. For number 1, the square of x minus 9. It must be written as open parenthesis x minus 9 close parenthesis squared. So that is the square of the quantity x minus 9 for number 1. Number 2, the square of the quantity x plus 12. Number 2, the square of the quantity x plus 12. Number 3, the square of the quantity x plus 3 over 4. For number 3, the square of the quantity x plus 3 over 4. You have 1 minute to do it. Okay. For number 1, squaring x minus 9 gives us x squared minus 18x plus 81. So we get a perfect square trinomial. Recall that the square of a binomial is the square of the first term plus twice the product of the first and second term plus the square of the second term. So the square of x minus 9 is x squared minus 18x plus 81. Number 2, the square of x plus 12, or the square of the quantity x plus 12 is, for number 2, the square of the quantity x plus 12 is x squared plus 24x plus 144. That is, the square of x is x squared. So twice the product of x and 12 is 24x, while the square of 12 is 144. So the square of the quantity x plus 12 is x squared plus 24x plus 144, which is also a perfect square trinomial. For number 3, the square of the quantity x plus 3 over 4 is x squared plus 3 over 2x plus 9 over 16. Again, the square of the quantity x plus 3 over 4 is x squared plus 3 over 2x plus 9 over 16. I think you are now ready for our lesson. You did a great job. Before we proceed with our topic, let me give you these thoughts to ponder. Mathematics makes complicated things simple. With the right amount of knowledge about the fun facts in mathematics, life becomes easier and comfortable. We just need to love mathematics, right? Try to consider thinking how businessmen decide on how much will they sell their product to yield maximum profit. Hello to our online sellers out there. And what dimension maximizes area? For the sports enthusiasts, what is the maximum height that the ball can reach, and how long will it take to reach the ground after throwing it up in the air? Your skills on quadratic functions will help us answer those questions. Let us start. Our Math 9 Week 6 is about quadratic functions. A quadratic function is one of the form f of x is equal to ax squared plus bx plus c, or y is equal to ax squared plus bx plus c, where a, b, and c are real numbers with a not equal to 0. The graph of a quadratic function is a curve called a parabola. Parabolas may open upward or downward and vary in width or steepness, but they all have the same basic U-shape. The general form of the quadratic function is y equals ax squared plus bx plus c. It can also be written in the standard or vertex form y is equal to a quantity x minus h quantity square plus k, where the point hk is the vertex of the graph of the parabola. We consider x as the independent variable, and its highest power is 2, while y is our dependent variable. Ax squared plus bx plus c is just a quadratic expression. Ax squared plus bx plus c equals 0 is considered a quadratic equation. Changing the equal sign with inequality symbols will make it a quadratic inequality, and having y is equal to ax squared plus bx plus c gives us a quadratic function. Let us have this activity. List down the following equations and tell whether they represent a quadratic function or not. Number 1. Y equals x squared plus 2x minus 1. Number 1. Y equals x squared plus 2x minus 1. Number 2. Y is equal to 2x minus 10. Number 2. Y is equal to 2x minus 10. Number 3. Y is equal to 9 minus 2x squared. Number 3. Y is equal to 9 minus 2x squared. Number 4. Y is equal to 2x plus 2. Number 4. Y is equal to 2x plus 2. Number 5. Y is equal to 3x squared plus x cubed plus 2. You have 30 seconds to identify whether they represent a quadratic function or not. Let's check your work. Number 1 is a quadratic function. Number 2 is not a quadratic function. Number 3 is a quadratic function. Number 4 is not quadratic function. Number 5 is not a quadratic function. Only equations 1 and 3 are considered quadratic functions. Equations 2 and 4 are linear, and equation 5 is cubic. Great! Quadratic functions. In terms of the table of values of a quadratic function, equal differences in the dependent variable x produce equal second difference in the dependent variable y. Again, in terms of the table of values of a quadratic function, equal differences in the dependent variable x produce equal second difference in the dependent variable y. Let us consider the quadratic function y is equal to x squared plus 2x minus 1. Kindly write this on your paper. Y is equal to x squared plus 2x minus 1. Creating a table of values for this function using -3, -2, -1, 0, and 1 as the values of x will give us the values 2, -1, -2, -1, and 2, respectively, after substituting them in the given function, meaning substituting -3 to the function y is equal to x squared plus 2x minus 1 gives us 2 as the value of y, while substituting -2 in the function y is equal to x squared plus 2x minus 1 gives us -1, and so on. Completing the table of values, it gives us first differences in x equal to 1, while we have -3, -1, 1, and 3 as the first differences in y. We can get that by subtracting two adjacent y values, while for the first differences in x, we can get those by subtracting two adjacent x values. With the first differences in y, the second differences will be 2. We can get that by subtracting two adjacent first differences of y values, meaning -1 minus -3 gives us 2. 1 minus -1 gives us 2. And 3 minus 1 gives us 2. So we have equal second differences in y. All quadratic functions will stand by the characteristic that equal differences in the dependent variable x produce equal second differences in the dependent variable y on its table of values. This is true to all quadratic functions. Let us now deal with the general form and the standard form of the equation of the quadratic function. The standard form y is equal to a quantity x minus h quantity square plus k of the quadratic function given its general form y is equal to ax squared plus bx plus c can be written using the formulas h is equal to -b over 2a and k is equal to 4ac minus b squared all over 4a. Again, to write it in the form y is equal to a quantity x minus h quantity square plus k, we may use h is equal to -b over 2a and k is equal to 4ac minus b squared all over 4a for the values of h and k. So the first thing to do is identify the values of a, b, and c. Let us write y is equal to -x squared plus 4x minus 1 in the form y is equal to a quantity x minus h quantity square plus k, or the standard form of the quadratic function. Again, for example 1, let us write y is equal to -x squared plus 4x minus 1 in the form y is equal to a quantity x minus h squared plus k, or the standard form. So using a is equal to -1, b is equal to 4, and c is equal to -1. Using h is equal to -b over 2a, substituting the value of a and b, we have h is equal to 2, while using k equals 4ac minus b squared all over 4a, we get k is equal to 3 after substituting the values of a, b, and c for the formula for k. Now, since a is equal to -1, h is equal to 2, and k is equal to 3, substituting them in the equation y is equal to a quantity x minus h quantity square plus k, we have y is equal to negative quantity x minus 2 quantity square plus 3, with 0.23 as the vertex of the parabola. So we get the standard form of y is equal to -x squared plus 4x minus 1 is y equals negative quantity x minus 2 quantity squared plus 3. So that is the first example. Example number 2. Let us write y equals 2x squared plus 4x minus 3 in the form y is equal to a quantity x minus h quantity square plus k. Again, for example 2, let us write y equals 2x squared plus 4x minus 3 in the form y equals a quantity x minus h quantity square plus k. Using a equals 2, b equals 4, and c is equal to -3, we have h is equal to -1, while k is equal to -5. We can get the value of h using the formula -b over 2a, while we can get negative 5 after substituting the values of a, b, and c in the formula for k, which is 4ac minus b squared all over 4a. Again, simply substitute the values of a, b, and c in the formula for h, which is h is equal to negative b over 2a, and also to the formula for k, which is equal to 4ac minus b squared all over 4a. Then substitute the values of a, h, and k in y equals a quantity x minus h quantity square plus k. So since a is equal to 2, h is equal to negative 1, and k is equal to negative 5, substituting them in the equation, y equals a quantity x minus h squared plus k, we have y is equal to 2 quantity x plus 1 quantity squared minus 5 with point negative 1, negative 5 as the vertex of the parabola. So, y is equal to 2x squared plus 4x minus 3 can be written as y is equal to 2 quantity x plus 1 quantity squared minus 5. Let us continue. Let us now reverse the process by writing the general form from the standard form of the quadratic function. Given the standard form y is equal to a quantity x minus h quantity squared plus k of the quadratic function, the general form of the quadratic function can be written by expanding the right side until getting the form y equals ax squared plus bx plus c. Let us have the first example. Let us rewrite y is equal to negative 2 quantity x minus 3 quantity squared plus 6 in the form y is equal to ax squared plus bx plus c. Again, let us rewrite y is equal to negative 2 quantity x minus 3 quantity squared plus 6 in the form y is equal to ax squared plus bx plus c. So, let us first expand the binomial x minus 3. Expanding the square of x minus 3 gives us x squared minus 6x plus 9. So after getting that perfect square trinomial, we now multiply it by negative 2, since we have a is equal to negative 2. So multiplying it to the perfect square trinomial, we get negative 2x squared plus 12x minus 18. Then adding 6, we get y equals negative 2x squared plus 12x minus 12. So that's it. So y equals negative 2 quantity x minus 3 quantity squared plus 6 can be written as y equals negative 2x squared plus 12x minus 12. Let us have the second example. Let us rewrite y is equal to 3 quantity x plus 1 quantity squared plus 2 in the form y is equal to ax squared plus bx plus c. So we need to expand x plus 1 or the square of x plus 1. Expanding it, we will have the perfect square trinomial x squared plus 2x plus 1. And then, since a is equal to 3, by distributive property, we get 3x squared plus 6x plus 3. And then, we add 2. So y is equal to 3x squared plus 6x plus 3 plus 2 will give us y is equal to 3x squared plus 6x plus 5. We now have the general form of the quadratic function y is equal to 3 quantity x plus 1 quantity squared plus 2 by just simply expanding the binomial and multiplying the perfect square trinomial by the value of a and adding the constant. It is just a matter of expanding the binomial and simplifying the resulting expression. Since you already know the basic characteristics of the quadratic function, let us talk about its application to the real-life situations and how can we model such situation into quadratic functions. Quadratic functions can be used to model situations and relationships in business, sports, and many other fields. See, for example, the path when a stone is thrown can be modeled by y equals negative 16x squared plus 10x plus 4, where y in feet is the height of the stone x seconds after its release. Again, the path when a stone is thrown can be modeled by y equals negative 16x squared plus 10x plus 4, where y in feet is the height of the stone x seconds after its release. With this quadratic function, the maximum height reached by the stone can be computed by getting the value of k, while the value of h with respect to the given quadratic function represents the time it will take the stone to reach the maximum height. In addition, the time to reach the ground can be computed by solving for the values of x when y is equal to 0. Doing so, from that quadratic function, it will take 0.32 seconds for the stone to reach the maximum height of 5.56 feet before reaching the ground in 0.9 seconds. For example 2, a common use of quadratic function in business is to maximize profit. That is, the difference between the total revenue, or the money taken in, and the production cost, which is the money spent. Businessmen always think on what selling price will give them the bigger profit. For this type of functions or quadratic functions, the value of h in the function derived by the economist will represent the selling price that will yield the maximum profit, k. Okay, we're good. We are now done with our enrichment activity. If you are interested in knowing more of those things, and I'm quite sure you are, study the sample problem on page 178 and get ready to earn more on your business. And if you want to know how you can make the most out of your limited resources and wishes to maximize area, study the sample problem on page 175 and enjoy bigger and wider spaces because of math. To check your understanding about what we have tackled, do activity 6, reversing the process, and do activity 7, where do you belong, on your Math 9 learners material. Again, do activity 6, reversing the process, and activity 7, where do you belong, found on your Math 9 learners material. Write your answers on your notebook. This is Teacher Gilbert saying hi to my fellow teachers, especially the Alamats and the Matitindes in BS ANS. Sulong edukalidad. Be safe everyone. I love you, wifey, and my dear Zafira. God bless us all.